All right, hello everybody. For today's video lesson, we're going to be talking about organizing outcomes. So for last day, we were talking about what is the probability of particular outcomes occurring. Today, we're going to actually organize those outcomes, okay? So we have a few ways of doing this. So we could use tree diagrams like we see over here, where we have the coin flip spinner and the outcome, right? This shows us all of the possibilities kind of like in a branch-like fashion. We can use tables to, again, to show us the possible outcomes of different scenarios. And we can also use images to help us kind of see what's going on. Okay, we will use pretty much tree diagrams and tables for today's. We'll save the diagrams for the art class, all right? Okay, so we got to go over some definitions first. So number one, independent events. So this is events that do not influence one another. So for example, flipping a coin. Regardless what you get on the previous flip, it's always a 1 in 2 chance of getting a heads or a tails on the next flip, right? Rolling a die, right? If you roll a 1, the next time that you roll the dice, the probability of rolling a 1 is just as likely to occur, okay? We call those independent events. Conversely, we have dependent events, and these are events that influence one another, or events that can, influence one another. So a good example of that would be pulling cards from a deck. And not replacing them. Right? So if you just have a deck of cards with all of the cards in there, right? Your sister, your cousin didn't take any. If you were to look for an ace of spades, if you pulled one card randomly, it would be 1 in 52 chance of getting that ace of spades, right? If you did not put that card back into the deck and you were still looking for that ace of spades, the possible outcomes is going to decrease by 1 because there's only 51 cards in the deck, okay? So we call those dependent events. And lastly, we have a sample space, and this is all of the possible outcomes. Okay, so flipping a coin, the sample space there would be heads or tails. Or if we were rolling a die, our sample space would be 1, 2, 3, 4, 5, and 6. Okay, so the sample space is going to show us all of the possible outcomes there. Okay, so these three examples here, we're going to say if they are independent events or not independent or dependent events, okay? So remember, independent events do not influence the outcomes of another probability, okay? Dependent events will affect the next outcome or the next probability, okay? So choosing a student from grade 7 and choosing a student from grade 8, these are going to be independent of one another. Okay, this will be independent of one another because they are from different grades, right? If we choose one marble from a bag and then choose a second marble from the bag without replacing the first marble, this will be a dependent event. Okay, and lastly, choosing an apple from one basket and then choosing an apple from another basket, this will be an independent event. Because we have two different baskets, okay? Excellent. Okay, so now for this example, we're going to represent outcomes with a table, okay? So we're going to be flipping a coin and rolling a six-sided die, okay? These are going to be independent events because if you get a heads or a tails on the coin flip, it's not going to influence what you roll on the die, okay? So we're going to use a table to list all of the possible outcomes. So it's kind of already divided up for us, but we are going to fill this in now. So if our possible outcomes, we could get heads and a 1. We could get heads and a 2. We could get heads and a 3, heads and a 4, heads and a 5, and heads and a 6. Okay, those are all the possible outcomes for heads. Now for tails, it'll be the same thing, but we're just replacing the H with a T. So a possible outcome is tails and rolling a 1. Possibility is rolling a tails, or is flipping a tails and rolling a 2. Flipping a tails and rolling a 3. Tails and a 4. Tails and a 5. And tails and a 6. Okay, these are all of our possible outcomes right here. Okay, so next question, how many possible outcomes are there? Well, there are 6 outcomes on the die, and there are 2 outcomes on the coin. So if we just multiply those 2 together, so 6 for die and 2 for coin. So there's 12 outcomes. And if you wanted to, you could have just counted all of them. That would have been just fine too. Okay, so next we're going to write the sample space for this combination of events. So for the sample space, we need to say what are all of the possible outcomes that could occur here. Okay, that's what we mean by the sample space. And that's going to look very similar to what our table actually looks like. Okay, so our sample space, we could have heads in 1. We could have heads in 2. Heads in 3. Heads in 5. And heads in 6. Okay, so that is the possible outcomes if we flip heads. Now we need to do the same for if we flip a tail. So we'll have tail and a 1, tail and 2, tail and 3, tail and 4, tail and 5, and tail and 6. Okay, so these are all of the possible combinations of events occurring. Okay, and that's what we need to provide if they're asking us what is the sample space for the combination of events. Okay. So moving on, so we're going to represent outcomes with a tree diagram here. So if we have a coin being flipped and the spinner is spun once, we need to show a tree diagram, okay? So we will start out and we will do like branches essentially. So we'll have heads and tails are our possible outcomes for the coin. But now we need to show the possible outcomes for the spinner as well. So we could roll a heads and a bear. We could roll heads and an elk. And we could roll or flip heads and spin a salmon. Okay, and we're going to do the same 3 for tails. So it could be tails and a bear. It could be tails and an elk. Or tails and salmon. Okay, so that's what a tree diagram looks like. And now we need to show the sample space for the two events. So this is going to look similar to what our tree diagram looks like. So the possible outcomes for these two events, we could have sorry about that. So we could have heads and bear. We could have heads and elk. We could have heads and salmon. And then we could also have tails and bear, tails and elk, tails and salmon. Okay, so those that is the sample space for flipping a coin and spinning the spinner. Okay. All right. So next question. This is our last one for the day. So Jeremy is choosing a tile and spinning a spinner. So we are going to organize the outcomes of these two events in a table. Okay. So we could have spinner in this column. We'll have tiger, bear, and monkey. And then the tile, there's a different color for that. So now we're going to do our 4 tiles. So we have hungry, sleepy, playful, and angry. Okay, so let's go ahead and fill in this table. Okay, so what are our possible outcomes here? Well, we could have a hungry tiger. We could have a sleepy tiger. We could have a playful tiger. Or we could have an angry tiger. Stay away from that one. Okay, we could have a hungry bear, equally as scary. Sleepy bear, that's a lot of bears at this time of the year. Playful bears, and angry bears. Okay, lastly, we'll fill out our monkeys. So hungry monkey, watch out. Sleepy monkey, playful monkey, or an angry monkey. Okay, so those, that table there is going to be representative of our sample space. However, for today, I'm going to make you guys write down the sample space, okay? Okay, so our sample space here, we could have a tiger that is hungry. Sleepy tiger. Playful tiger. Angry tiger. Okay, now we'll do the same thing for bear. Bear hungry. Bear sleepy. Bear playful. and bear angry. Okay, lastly here, we will do the same, but for the monkey. Monkey hungry. Monkey sleepy. Monkey playful. And monkey angry. If you guys like monkeys, you should go to Asia. There are lots of them over there. Okay, so there is our sample space. And lastly, are these outcomes independent or dependent? So these outcomes are going to be independent of one another, because if you spin a tiger, the next time that you spin the spinner, the chances of getting a tiger is going to be the same as it originally was. Same with the tiles. As long as you are replacing the tiles, they will be independent. All right. So that is it for examples for today. So now I would like you guys to work on questions 5 to 7, 10, and 12 on page 169 in your textbook. Okay, if you need any help with those, please just ask. I'd be more than happy to help you out. And other than that, hope you guys have a wonderful day.